Bismillahirrahmanirrahim. Dear students, I am Ahmed Mumtaz Mustahsin, your teacher for CSC 141 Introduction to Computer Programming. Students, we are studying iostreams, and today I would like to complete that topic that was continued from the last lecture. So we have seen the iostream as a object, C in and C out object, and I have introduced two more objects, which is C error and C log. C error is the unbuffered output, mean whatever the error is there, it is immediately printed onto the screen or wherever the console you have defined. Where the C log is an object that contains a buffer and all the messages are saved into the buffer. Once the buffer is full, then output is printed and buffer is flushed, means it is emptied. So iostream member function, peek, putback and ignore, these are the member functions of iostream. So the ignore member function, first of all, it skips over a designated number of characters and by default is 1. Okay, it terminates upon encountering a designated end of file, और मैंने आपको बताया कि default end of file in our case is Control Z. So it's mean that it skips to the up to the end of the file. You can ignore it. By default it can ignore one character, or you can just provide the designated number of character that you want that should be skipped from the, or you the iostream may ignore it from reading it or extracting it. Okay, putback member function places the previous character obtained by getback into the stream. So you just at any stage you can adjust your stream by just either ignoring a character that will take it out, or you can put back a member. So that is whatever the characters precisely you have it, means a byte that you can either insert it or you can either ignore it. Peek returns the next character from the stream without removing it. So the stream means you have already got the characters which are available into the buffer, and the buffer is not flushed unless until you flush it by yourself. So you just read the characters one by one. As soon as you read a character, the pointer moves forward as if you have read it, mean take as if you have taken the character out of the stream. But peek means without reading, you can read it without removing it from the output the stream. So you can just peek means you can just look through it, what is the next character coming in. So before using it you can just see that what could be the next character that you are going to encounter. So it has got some significant usage, and that significant usage you will learn in future. So type safe IO, that is overloaded to accept data of different type. What does it mean? But it's mean that if you are not sure that what type of input, whether it's a character input is going to be inputted, or it's a float input it's going to be inputted, or the double input is going to be inputted, or even you are using a characters. So for that purpose you can use a type safe option, and program stays in control. Program does not terminate. Otherwise, if you want to read the data and system is expecting an integer and you are typing the number in decimal, then it might have an error message, and this error message might terminate your execution. But for the type safe, it stays there and allow you to handle the data, whatever data you have entered in. So unformatted IO with read, gcount and write. We have used, I think, read and write member functions while handling the files. So we can perform the reading unformatted input and output with the read. Input is from the read and output is from the write. So since the data is unformatted, the function will not terminate at a new line character. Do you remember when did it ended? It ends while that you assign the system to read a block of characters, block of data, and then you enter the end of the file function. So instead, like getLine, they continue to process a designated number of characters, so it will keep on reading the data, so it will not terminate it unexpectedly. Means since the data is unformatted, the function will not terminate at a new line character, because you cannot find out where is the new line. So it will keep as if you are reading a complete stream, and it will provide you the complete stream into your buffer. But mind it, you have to provide the buffer also, and you have to maintain the size of the buffer also, and that we have done it while we were handling the files. So instead, like getLine, you can just continue with that, and if fewer than the designated number of characters are read, then the fail bit is set. I said that the fail bit is a flag. So if you have defined that this much number of characters you are required to key in, but if the number of characters are less, then you have designated the function to read in, then it will not terminate your program. Rather, it will set a fail bit. So then you can test the fail bit, and then you can take the decision accordingly, whether you should rely on the data that you have read it from the stream, whether the stream is coming from the keyboard or it is coming from somewhere else. What is somewhere else? We can say that it could be any input device, or it could be any other device. So for example, you are reading it from the internet, or you're reading it from certain port, and the data is you are reading it. So you can take the decision regarding the fail bit, you can test it, and then you can take the decision. gcount returns the total number of characters read in the last input operation. If the number of characters or number of bytes are less than the designated number of bytes, then you should also have a mechanism that how many bytes then the system has read in the last operation. For that purpose, very logical that you should have certain facility, and that facility is provided with the help of gcount. gcount member function. These are all member functions that you can use it. These are all the facilities: read, write, and gcount are all the functions, member function, providing you facilitating you with the different facilities in the iostreams. So let's take an example here. This is we have just said that the system should read 80. It's a const size is 80. We have defined a buffer of 80 characters. Then we can set that, as in the last explanation said, that you can provide with dot read the number of bytes that you want to read in. So it's the number of bytes is 20. So you can cout enter a sentence, and you set the system to read the 20 bytes. And cout, the sentence entered was cout write and c in gcount. You are not sure that you have entered 20. You expected it 20, but then you say that instead of giving this number, you can say that c in gcount, and this gcount is the number of bytes rest in last operation, last input operation, c in operation. So c in gcount was that, and cout gcount could be this one. Okay, but we are using it c in gcount, so it is this one. So we can just write it down here. So this is the output here. Enter a sentence using the read, write, and gcount member functions. The sentence entered was, this was the enter a sentence, and you have entered this sentence using this one, using the read, write. Okay, you have keep on typing it, but since you have limited here, it should be 20. Okay, so it is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Okay, and then okay, it's also it's reading it, and it's also writing it. So since you have written here 20, so it should give you that this is the gcount here, that is the last successful number of characters it has read. Okay, stream manipulator capabilities. Up till now we have gone through all the capabilities of the iostream with reference to the member functions. But now the similar facilities are also available, and you can have some control on the format as well with the help of stream manipulator capabilities. With the help of these stream manipulator capabilities, you can set up the field width. जैसे कि scanf and printf के अंदर you were able to control the field width. Here you can also do that. Then setting the precisions, how many decimal places up to after the decimal, you can set the precision. Setting and unsetting the format flags, bit fail flag or bad bit or bad operation flag, you can always set and you can always reset. Flushing streams, you can clean the buffers with the help of flushing streams. Insert a new line in the output stream and flush the stream. Insert a null character in the output stream and skip white space in the input stream. These are all the format specifiers and capabilities that you can perform with the help of stream manipulator capabilities. So, integral stream, which is base, decimal, octal, hex, and set base. This is very interesting manipulator function. Suppose you want to set up that a number that you have read it, you want to use it, or you want to print it into the hexadecimal format or into the octal format or into the decimal format, that you can always do that with the help of this wonderful facility that is provided in the stream through stream manipulator. So it is integer n is equal to 15, then you can say cout hex, okay, \n. So this n will not print here as a 15. Why? Because you have set this cout and you have used here manipulator capabilities, and with the help of these manipulator capabilities you can set the base here. And base could be decimal, octal, hexadecimal. And since you have set the decimal, hexadecimal, and decimal 15 in hexadecimal is F. A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So 15 will be printed as F. You can also set the base. So you can change the base of the integer output. So you can use this. Load means you will include, not load, it should be include IO manipulator header files, and then you can just use cout set base 16. 16 means hexadecimal. So this is the same thing. You can use that set base function, and that is the same setting it has carried out. Okay, so parameterized stream manipulator takes one argument. This is a parameterized stream manipulator. Okay, this is done with the help of member function, some task, and some tasks you can do that with the help of this parameterized manipulator. So this is a parameter 16, and this is set base is a parameterized manipulator. So here you can see that this I will show you when they doing some hands-on examples. Maybe I'm planning one for you. So you can define here using std hex, decimal, output, set base. So these are all that you are going to use it. These are IO manipulators, and these are manipulators is you can do that. We would like to use hex, decimal, out this one, and we would also like to use cout and cin also. Okay, and here you are using cout, enter a decimal number, read that, and then here in the output in hexadecimal is hex, it will print value of n in hex, then in decimal, then in octal, and then you can also set parameterized set base again to 10, means it should again print into the decimal value of n in decimal is this one, and then you can print the value of n also, that is after this parameterized. So it should be whatever the number here in decimal, and again it will print at a new line return. So what output we will get? Here we will read a number. Suppose you have entered a number 20. So you cout and 20 in hexadecimal. 20 in hexadecimal is hex. So 20 in hexadecimal is 14. 20 in octave is, now it will print in octave because you have used here OCT, and it will print 20 in octave is 24. And then set base, you have set it back to decimal. So you have parameterized this function, this manipulator. So you will provide a parameterized, mean 10 is then argument or the parameter, and which is equal to 10. So it will set it back to decimal 20 and you will get the output. So it's very simple, but you can read the data and then print it up into any format. This is very, very useful for you to see and the values of different ASCII characters, and you can just print it into the hexadecimal or into decimal or into the binary value. Okay, floating point precision. We can set the precision with the help of precision or set precision. So precision means it's a member function. You can use it as a member function. So sets number of digits to the right of the decimal point. How many places up to the decimal you want to print. So if you want to use it as a member function, so you will use cout dot precision 2. And cout dot precision will return the current precision setting. So you can use it as a member function. And set precision, we are using it here as a parameterized stream manipulator. You can do it as a member function here, or you can do it as a parameterized. Here is a member function. You have set it up to precision 2, and then you said that the precision will give you how many precision you have set, and here you can also use it like that, cout set precision 2 value of x. So both methods change the last until different value is set. So whatever you will set remains there throughout the execution of the program until you reset the previously defined value. So in this particular example, if you have set it up, so here we are using it as a iostream object, so you can use it this part for the as a member function, but you can also in the same program you can do it as a IO manipulator. So it's a parameterized manipulator, you can also use that. So in this example we have seen that double root 2 is equal to square root of 2.0. Integer places is the number of places. So we can set IO flags. We can also set IO flag with iOS. This is the function that we want to use. Set IO flag, that we have defined it here up to a fixed number. Okay, later on we'll show you that how can we change that. Square root of 2 with precision of 0 to 9. Then precision set by the precision number function that I will show you later on here. For place is equal to 0, place is less than equal to 9, place plus plus. So for example, you have defined that you want to use it the places, and how many places? Up to 9 times. Okay, initially the place will be equal to 0, so we can have cout precision place. It's 0, so after decimal places should be 0, then it will be 1, then 2, then 3, then 4, 5, 6, 7, 8 and 9. That you can do it with the help of member function. Here we are doing it again, but this time we are doing it with the help of set precision manipulator. We can do it with the help of set precision manipulator once again by using this parameterized, or that we can use set precision places. Once again it will be. So both of these loops will do the same thing. One is the job that is done with the help of member function, that is the object member function of the class, and the second one is the parameterized facility that is available in your language. So the output should be I guess should be the same. Yes, square root of 2 with precision from 0 to 9. This precision set by the precision member function. So place is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8 up to 9. So this is up to 9 places, first output of the first for loop. Then the output of the second for loop, where we are setting up the precision with the manipulator. Once again we start from the 0, so no decimal place from 0. It is starting from 0 means no, you don't want to have show the any part of the fraction here. So then you can just keep on adding it at 1, 2, 3, 4, 5, 6, 7, 8 and 9 times. So both the functions are doing the same thing. Okay. iostream width member function. So once again you can use the set width member function as we have done it in the format specifier of scanf and printf function. This time you can also do that, and the character position of value should be output, or a number or a character that should be input. So this is much easier and much more convenient as compared to printf and scanf function. So it returns the previous width. If you don't want to reset it, you can see that C in width, it will give you the previously set width. I think it should be also printed here. If the value processed are smaller than the width, then the fill character inserted as a padding. If you have to find a larger width and the number of characters you have provided are smaller, then it will fill up the character as a padding. And you can also define the character that should be used as a padding of these. Padding means by default it is space, but if you want you can use zeros also as a padding, or you want to use some other character as a padding. So you can set with the help of here is the member function and here is the manipulator. So both are doing the same thing. C in dot width 5, it will print set the width 5 and read the data in 5 positions. Okay, position means 5 places you have reserved. Okay, then C in set width 5 and string. So you have to reserve 1 space for the null character also. Here, this is the string of 10 you have defined. Width is equal to, so W is equal to 4, and here you say that C in width of 5, that you have set this string, and set the width up to 5 decimal places. And here you read that the data C in string, C out dot width W plus plus. Here after using it you will set it to 5. C in W plus plus, so W will be equal to 5. So it will set the width up to 5. First of all it will use the value 4, and next it will be for 5. So C out string, next time it should be the 5, then C in width 5. So what output you will have? This is enter a sentence. This is a test of the width member function. So 1, 2, 3, 4, 5 is, this one is you are using it for a null character. So this is again you are just keep on just printing it because you have set the width here. So after the width, after this string width, it will be just in the loop, it will write down the data, but one time it will be just printing up to the not more than 5 characters. And for after every one it will be writing at the end of the line also. So the whole string, whole sentence will be printed in the form of this is the string. So it will be just reading it here, this C out, enter a sentence. Where is that? Sorry, this is the out, enter a sentence, and then set the width by C in string. Now it's reading the data. Okay, it's reading the data. This is the data you are typing. This is the test of the width of the member function. So it is reading the data with the help of the set width string. So it will put it up there, and then you can just place the output over there, and this is the output over there. So you can have a control. This was just the sample execution. User defined manipulators. Bell return means carriage return. Tab end line, that you can define it as a stream manipulator, and you can use it a parameterized stream manipulator. Instead of explaining it, I will quickly go through it with the help of an example. And in this example you can see that this is the comment, and you can see that iostream address bell, iostream output. So this is basically iostream that we are going to use it up here. This function will return output \l. Okay, so this is ostream address return. This is the table that will contain all these function names, and here is the data that you provide and what it returns. This function basically returns, simply it returns a \a, that is a bell, carriage return, tab, new line, and this is the ostream end line function, that is the output here. And then you can say the return, this function will return the same thing, just like that, but except that here I've just explained it here instead of putting it up in one single line. So it's, you can just use it. This is the end of all the definitions of the functions that you have provided here, and then simply you can use it here. End line, this A tab, B tab, this end line. Testing the rest of the bell manipulators like this that you have already defined, and you can output the result of that. So you can do some exercises there. I'm just leaving it as a sample, and you can just try it out into the environment and see the result. So there are a lot more very simple and basic concepts that you can easily test and verify. So that's why I'm going a bit fast, so that just simply explaining it to you, and so that you can just use it. Stream format states. Format flags, I said that there are a number of flags that you can always set and reset. Set means you are setting a flag to value 1, means the flag is set. Reset means you are setting a value of flag equal to 0. 0 means the flag is reset, so it means that it will not take place. Setting means that it will take place. So specifying a formatting to be performed during stream IO operation, you can set a flag and you can unset a flag. That is, whatever the setting you have done, you can do that with the help of unsetting the flag also. So unset 1 means resetting the flag and flags. So member function that control this flag setting, just don't worry if you just find it a bit more complicated. I'm just giving it to you as a taste. Okay, if you understand it, if you can use it, well and good. Otherwise, in the next course, when we will teach you the object-oriented programming, the teacher, whosoever will spend sufficient time to explain each and everything to you. I'm just giving you a quick run through of all the facilities that is available, so that you can have a taste of it. Okay, so just relax and just try to listen how much you can just understand that. So format of state of the flags is defined as enumeration in class iOS. Enumeration means you can start with any number from 0, 1, 2, 3, 4. We keep on increasing with the value of 1, that we already know with reference to the enumerated data type. So it can be controlled by the member function by specifying the value representing the setting of all the flags, or you can find out what are the flags value which are being set. So you can use setf, one argument, and that is or you can OR it. This ORS means OR. This OR means you can OR number of flags together. Okay, so isko OR means आसान उर्दू में combine, join, because the 0 plus 1 means 1, 0 or 1 means 1. Okay, so that's why this is OR's flag with existing flag. Or unset flag, you can unset a flag also. So set IO flag, parameterized stream manipulator used with set flags. And you can also reset the flag which is parameterized. So flag can be combined using bitwise operator. You can set different flag by using the OR, combining together. If you want to set flag A, if you want to set flag B, you can say A or B. Set flag A or B. This is the format of the state of the flag. Skip WS, skip white space characters on input stream. If you want to skip the white space characters, as I said in the example, as soon as you use C in captionalized or whatever, space, something else, so it terminates by automatically. But if you set the flag that skip white space, then it will skip the white space and keep on reading the data. Left means you can justify the field, then you can have a right justifier, and the padding of character appears to the left if necessary. Obviously, if you are justifying to the right, and if the number of characters are less, then the additional character means are padded up together. They can be padded up and they can be added. So left justification may the padding is done on the right. For the right justification, the padding is done on to the left also. Internal indicate the number sign should be left justified in the field, and the number's magnitude should be right justified in the field. The plus or minus should come on the extreme left, and the magnitude means the data, that is the whatever the value of the float or the integer is, it should be right justified. इसका मतलब है कि the plus or minus should be on the extreme left. Or what is the gap between that? It is the set width value that determines how this should be organized. So you have a very controlled output that is facilitated with the help of this iostream. So I advise you to read it out. I have already touched decimal, octal, hexadecimal, then show base. What is the default base that you have set yet? You can use it with the help of show base. Show point. Show point means floating point. Floating point is specified that the floating point number should be output with a decimal point. Means you have to show the point also. This is normally used with the iOS fixed to guarantee that a certain number of digits to the right of the decimal places will be printed. Okay, so you can set up by saying that you have to show point, and you can have the accuracy also. Okay, how much precision you want to set it up also. Uppercase means this hexadecimal number system, you can print it out in the lowercase, that you have for 15 it will print uppercase, it will print uppercase F, and for the lowercase it will print the lowercase f. Okay, show position, show positive or negative number should be proceeded with plus or minus respectively. Scientific notation, you can just set it up also. And then fixed, that is important, that I have already used it and shown you how can you use it. Specify the output of a floating point value in fixed point notation with a specific number of digits in the right of the decimal places. Whatever you want to set it up with the fixed notation, you can use it in the output. Trailing zeros and decimal points, that you can always control. So that is a very good example here. You can say that forces the floating float with an integer value to be printed with its decimal point and trailing zero. So suppose you have said cout set flag show point. Up you are saying that cout 79. There is no point here, but since you have set the flag show point, it means the system is bound to put a point here, and then fixed means it will show some zeros also. So 79 will be printed as 79.00000, the number of zero determined by the precision setting. So show points के साथ you can always combine the precision also. How many decimal places after the decimal? Obviously, if you are showing a point, you are showing a decimal point, then you also need to specify how many digits after that decimal point. So this 79 will be automatically printed at 79 point, and these 5 or 6 or 3 or 2 will be the precision that you will set it separately. Okay, this is the example here. In this particular example, we can set here the member function C in cout, and I have also shown you that instead you can also use that using namespace, and then you can use C in cout and end of line also. So you don't need to use this using std count, std in, C in, or std end line. You can simply use iostream and using namespace std, that we have been doing it in the past also together. Then you can use this cmath is a mathematical library function. Something will be using that. So this is the before setting up iostream showpoint flag, whatever the default setting is, and we are printing here 9.990. Then backslash n, we are doing it again 9.9000, then 9.000. After setting the show point, here we have not set that show point, and here we set the member function cout.setFlag show point. Okay, and then repeating it again 9.990, 9.9000, 9.000. So what you expect, if this is there and show point means you have not set that, then the output will be, before setting the show point, 9.9900 will be printed as 9.99, and 9.9 will be printed as, because the zeros after decimal places have no significance, so by default they are not printed. Here, previous example, 9.9900, but you have said 9.99 and you have mentioned that, but at the time of printing it has not printed it. It is not printing here, it is not printing here. So this this go back, 00, 000, 4 zeros are not printed. So in the output you have got 9.99. But when we have executed here and we have performed here, called the member function cout set flag show point, and then we have by default automatically up to 5 decimal places showing 99000, 94090. Okay, this is the use of this show point. Left justified, usually we use that, and this justification is defined in the top iOS stream, that is left, right, internal. Internal I have already explained it to you in the previous slide. So you can feel to be left justified with padding characters to the right, for right justified the padding character to the left, and that is also the default setting of the numbers, integer numbers. Character used for padding set by the fill member function. As I said, that default padding is for the space, but you can set fill parameterized with the help of any character that you wish. So here in this particular, I'll show you the help of example also. So internal flag, that is the number sign left justified, the number magnitude right justified, sign extreme left pe aata hai, number then comes on the extreme right, and intervening spaces padded with the fill character. So darmiyan mein, if you have not defined the fill padding character, by default it is spaces, but if you have defined, then that whatever you have defined will be used as the padding for that. So the left, right and internal flags are takes place as static data members, and they use it as a adjust field. So you can use adjust field this member function. With the help of that you can perform left, right and this one. So iOS adjust field must be the second argument to the setf function. So first of all you need to set the flag iOS. You want to do left, you want to do right, or you want to do internal, that is default. So you can see that iOS left, and then you can say adjust field. So that will take place. So that's why I say that it should be the second argument. These are the predefined features basically. So you cannot argue that why it is second and why it is first. It is predefined feature. So you just need to go through it and spend few minutes, and this is the one time, if you spend one time in the hands-on environment, then you will remember it always, and it is very, very helpful for you. So I'm not going to explain it. I've already said that this is for member function, this is for parameterized. So parameterized, you can see that is set width hai, set iOS flags hai, and reset iOS flags hai, that we would like to use. So we can have x is equal to 1 2 3 4. Default is right justified, that we would like to see if we use parameterized set width 10, and then we have used 1 2 3 4 5, but we have set width of 5. And then Nothing member function. It is basically not using member functions, not nothing. It's backslash and backslash n, using member functions. Okay, this is parameterized, and set with w, and use set with the help of this left justified, and set with this one. This is just a string, not left justified. We'll use it in the next here. Here we will perform cout set left. As I said, you need to put the flag here, and then you can use adjust field, whatever you have provided with reference to the first argument. Cout use unset function to restore the default. So then you can use unset kaun sa? You have justified that you have used it here. So this way you can use set flag for setting, unset for resetting for the default. So this you have set, you can reset it. Cout set with 10x, and then again using parameterized, and here you say set with 10, then set flags to have justified. You can set it, use it, reset it, use it. So default is right justified, so it was set with 10, so it has used by default 5 spaces and then the 5 characters here. Using member function, use set field to the set this one left, that we have done it up here, and then it is left justified. Restore the default here, once again it is restored and it is there. Now using the parameterized, the same thing we can do with the help of parameterized set width, set flag function, and this is this one, 1 2 3 4 5 left, and then you can come back by the default parameters. Okay, and this is the simple internal show point. This set width 10 1 2 3. This is basically the 2 flags, internal or show position. This is not show point, it is show position. So you have set that, and then you have set this with the width also 10 characters. Internal मैंने आपको बताया था, it takes the plus minus on the extreme left, then the show position, and then it is basically the right by default because it's an internal. So the data, the magnitude on the right, and the sign which is minus or plus is on the left, and here is basically the default padding which is spaces. Here we can use, instead of spaces, we can just use fill bits also. With the help of fill bit member function, you can specify the fill characters, and you can use the space as a default. So you can fill static, or then you can use either with the help of this cout.fill, okay, or you can use it as a parameterized or manipulator, which is set fill with this one. Both will perform the same task. Both will perform the same task here. So you can see that manipulator to change the padding. This is what we have been doing that. I will show you the shortcut of that. It is for, instead of writing each and everything, you can do that using namespace std standard. So this is the initialized value, and then we can use printed into the right, and we have justified show base. Okay, it will show base mean radix, which base you want to see. Then you have set width 10x, this one, and then cout set flag left justified and then adjustable. Cout set width 10x. Here you see this should be the default and this should be the value. Okay, and it also, we have just set the show base also here. Internal, you know that the magnitude is right, and justified field means this plus minus on the left and magnitude is on the right. And then cout set width 10, you want to show it in hexadecimal. Yes, you can do that. Value of x is shown in hexadecimal. Then using various padding options, so you can have a right justified, and then you can cout fill with static. Then you can do that set fill with percentage sign. So set width 10, decimal, show it in decimal value of x, adjust it, left justified it, set weight 10, but this time the padding is, here the padding is of static, here the padding is of ampersand sign. Okay, internal, go back to the original one, but this time the setting is, padding is for this ampersand, this sign, cap sign. Okay, so should have a very interesting output here. This 1000 printed as a internal right and left justified, and an hexadecimal with internal justification. So using the default padded character, which is space, 1000 is printed like that. Then we said that put the 1000 into the left justified, so the padding has gone on to the right side and 1000 will come up here. Then we said that show base here, and then printed the value of x. Show base hexadecimal, we use 0 and x. Octal starts from 0, and decimal with nothing, neither from 0 nor x. It is printed as it is. So this means that it is hexadecimal output. So 1000 hexadecimal output is 2710. That is equal to 1000. Then using various padding characteristics, we have carried out the padding with the help of static. So we have made it left justified, and we have this, here the right justified with padding static, then left justified and padding with percentage. So the output, where is the output? Here. Right justified with padding static is here, left justified with padding of percentage sign here. Then go back again, and we have sent that the show base also, and show base, and then we have provided the padding with the help of capsule. So you can control all type of the fill character also, padding character also, and then you can adjust your output as per your requirement and as per facilities available. So base field, that I think I should leave it here for your convenience. The slides are there, examples are there that I picked up from your book and put it up here. So let us see. Scientific notation, yes, just you can just control with the help of scientific notation. I think it's simple. You can just go through it, read it out, and try it with the help of these slides, with the help of examples there. So all the definition I have provided, because I would like to spend 10 minutes in the hands-on session. So this is the example output. You can use that, uppercase, you can use that. So I'm leaving it here for all these slides for you, and I expect you that you can go through it and try it. The explanation is detailed for your convenience, extracted from the reference book also, and you can read it out and try it out and go through it. So I would like to spend 10-15 minutes giving you some hands-on that I could not complete it in the last lecture. So we can open up our environment here. That is the Visual C environment, where I will open up these files. So let us create a new project today, so that you can have some revision also. New project, empty project. This should be demo 3 is there, demo 4, demo 5. Let's say it is demo 5. Okay, so it will create an environment for us. So by default it will provide you all the files over there. Then here I would like to add new item in C++. Okay, and this is P random file creation. Okay, so just to save time, we can just copy the data from here, Control C, put this data back here, Control V. So what this program is doing, a quick revision, client data structure, that is simply we have I need to correct it also, structure client data, unsigned integer, account number, and character last name, character first name, that's okay. Then unsigned integer here, structure client, which is equal to client data table blank client, is a blank client that we have defined. Then we do have defined a pointer to a structure here. Then here, structure client data. Okay, that seems to be all right. So what this program does, basically creating a random access file sequentially. This is the structure that we have defined, a client data structure that has an account number, last name of 10 characters, then first name of 10 characters, 15 characters, 10 characters, then the account balance. So this program will here we'll call this the structure that you have initialized. Remember that if we are creating a random access file, then we need to initialize each and every record so that each record size is fixed. So we need to fix down initialize the data. Once we initialize the data with 0, it's mean that the account number, the last name, first name, they are all initialized to null characters or zeros value, but the size will be fixed here automatically. Okay, then we will open up the file that we know it already, and then we say that this is the file we are going to open it up in the binary format, and we are opening a file in a binary format. If the file does not exist, then it will create a file. The name of the file is credit.dat. Then we are creating a file for 100 records, so we are using it in a for loop, and here we say that fwrite, and we are providing this structure, this address of this structure. This is address of blank. What is blank? This is blank, right? We are providing this address here. Then size of structure client data. Then 1, it will write it one time, because for array you can give it any name, any number of times that you want to repeat the data here. And this is the file where you are going to write down. After creating this file, you can just always close it. So let us build this file. Successful. So it has, just try to show you because we can't see it, so because it has created a blank file. So what I can do here, I can put system pause. So I need to put iostream also, include stream. Okay, and now I build it again. Successful. Then this time it should stay here. So just to confirm you that it works. So basically it has created a file. It has created a file which is basically contains an empty record over there. Okay, in the next example we will put some data in this random access file. Okay, creating a random access file, and this time we are going to open it again and we are putting the data. So I just simply copy, I'm not saving it just to save time, Control V. Okay, slide editing, structure, struct, client data, integer account number, character last name, character first name, structure, client data, blank client, structure, client data. Okay, and before return, just okay, build, successful, run here. So it's not writing here. I think I've copied 11.11. It's basically creating a random access file client. This file not be opened. Let me see. Writing to a random access file. In fact, I should have copied this one, writing to a random access file. So it contains iostream also, it contains everything. So it should not take much time. Control C, put it back, Control V, client data, integer account, character last name, character first name, int, it should be int, actually T was there here, so I put a wrong place T here. Now it is there. Because we have copied it from there, so this character is not recognized. So just need like, okay, iostream is already there. This is not necessary, you can have a space also. So let's hope it is there. So what we are doing in this particular file here, that we are again opening it, but this time we will enter the account number from 1 to 100, 0 to end the input. Then we read this account number, client account number, and then while client number is not equal to 0, we will keep on asking you the last name, the first name, the balance, and then we will write it down onto the file with fscanf, this one that we will be writing it out. Then the first name, last name, first name, and then we need to seek. What does this seek do? Seek basically puts up the pointer I've explained it to you that it puts up the pointer to the specified location before writing it. So basically you put seek this, multiply by this client data structure, okay, account number -1 multiply by the size of the account, and then seek set means put the pointer over there, and then you will keep on writing the data. Okay, so let us create a file. First build, enter an account number from 1 to 100. So let's say account number between 1 to 100 is let's say account number 21. Enter last name, first name and balance. Last name is Mumtaz, first name is Ahmed, balance is 45,000. Enter the account number let's say 23. The last name is Babar Avan, and balance is 190,000. Account number 34, last name is Zafar Qazi, account is -50,000. Last name is Khalida Rashid, and account is 0.0. Account number 67, Zahid Ahmed, -440124. Okay, this should be sufficient. And then program says enter 0 account number to end, press any key to continue. So we have created a file. The important point that you should remember that it is just like the sequential file, but here first of all we initialize the structure, whole structure, and then whenever we are going to write it, the most important point is that you need to place the pointer. So we have already created a file that contains 100 record. This time we have opened up the file credit.dat, and we have opened up the file for reading and writing. R plus means reading and writing, B means it's a binary file. So we have opened it up in the mode RB plus. That the one point that you should remember. Second, that we need to initialize this structure so that each and every record should have a same size. Then print account number, that the file that we have already created contain 100 records. Here we have just entered the account number, and then before writing it into the file, this is we are reading the data. Before writing it into the file, that we use fwrite function. We have used the fseek, that is the most important thing that is not there in the sequential file. In the sequential file, we just keep on writing at the end of the existing file. But here, first of all, we need to determine the position. Position is the account number -1, because the first record starts from the 0. So it is always account number -1 multiplied by size of each and every record, which is basically the structure of the client data. We multiply it to that, and then we, with the help of this seek set, we set the pointer, position the pointer over there. When the pointer is positioned over there, then we can use this unformatted write, means you are writing a complete binary block, and that binary block contains the data of the client and the size of the client and the number of time you are going to write that block, and to the file control block or the file pointer where you have opened up the file. And then this is all the logic over there. So we have written the data into the file, and that's okay. It's mean that we can just save it up, and now we can just use another function, random access file, reading the random access file sequentially. The file that we have created, now we can read the data randomly or we can read the data sequentially. So we can copy it again, Control C, quickly adjust it. Last name, first name. Hope we have not made any mistake this time. Structure, client, data. That's okay. So just to put include iostream. Okay, so this time we are going to read the data, but we can read the data, we can create a random access file and we can read any record, any specified record, but if we like we can read the record sequentially also. So we can read the record, we can specify, and then we can just read the record sequentially one after the other. So quickly would like to show you build, and then so this was the data that we have entered. That file contains account number 21, 23, 34, 67. These are the name of the account, first name, last name. These are the account information that contains. Okay, so quickly the last part, which is reading and random access files sequentially, that we have done that. This is a complete project basically that will cover each and everything for whatever we have done. So just be patient, that this is going to be the last demonstration of this lecture, maybe the last demonstration of maybe the last demonstration of this course also, but I will always be available during the time, and the TA is also available. So if you want, we can just arrange few more demonstration sessions and we can help you out in carrying out these assignments and lab sessions. So copy and so we'll take few minutes to adjust a lot of spaces here. Structure client, int account number, character last name, character first name, integer enter choice, void text file that you want to read, void function update record, void new record, void delete a record, So in this particular example, we will be doing everything. We will be reading the data, we will be updating the data, we will be deleting the data. So from the random access file, we will read randomly as per our desire, as per requirement of our application. But first of all, we need to correct, because whenever we copy, we have seen that the spaces are deleted automatically, but still we can still save a lot of time. Instead of typing each and everything, we can copy the examples. Structure, client, data, blank client, integer, account, so we are almost at the end. So this is the definition of the function. Integer, enter your choice, menu, return menu choice. Okay, so it's very convenient. We can still see that if there are red lines, then it's mean that some editing needs to be done also. So let's hope. So I'll quickly explain it to you. This program that reads the random access file sequentially, update the data already written to the file, create a new data to be placed in the file, and delete data previously in the file. It can do anything. So it has defined the account number, last name, first name, and balance, same structure. These are the prototype functions. Enter choice, what you want to do. Text file, that you read the data and create a text file that you can print it out onto the printer later on. Then void update record, and then new record, that you want to add a new record. You can delete a record, so that we would like to do. And these are the definitions. So everything you have seen that, but just this time we would like to see its function. Okay, so we will open up the file, and the exist, if it cannot be opened, then it will say error message. Account.txt is a new file that we are going to create. This file that you can print it out onto the printer also. Then you can perform the formatted read write operation, printf, but since it will be done on the file. Rewind. Why we are using rewind here? Because after every choice we can just go at the start of the file, and so that then take the next choice and accomplish that, follow that as per your input and as per your requirement. So this is the complete project that is given available. We can just run it and say it. I think I have already explained it at the time of teaching that particular lesson. So let us pray that it does not have any syntax error. That's good. Successful. Run. Okay. put it up here. Enter your choice. One is to store a formatted text file on account card account.txt for printing. 2, update an account. 3, add a new account. 4, to delete an account. And 5 is to end a program. So we can do that by let's say 1. So it will create a file that will see that it will create. 2, update an account. So let us see, update an account. Enter the account number. Do you remember any account number? I remember it was, let's say, account number 23. So it is Baba, and it is doing that. It has got Baba Ravan, and plus means to add and minus means to subtract. So you can say minus, take out 67,000 rupees. Okay, update an account. Let's see whether it has updated or not. Again 23. Enter your choice. Okay, 2. Enter your account number. Let's say 23. So you can see that it has updated it. It was 1,90,000 minus 67,000. Now it has got 1,23,000. So this time I add 78,000 more, and then I can see update to account number 23. So it is updated. So then delete an account, add a new account. First of all, add a new account. 3. Add a new account. 3. Add a new account. So let's say I want to add account number 99, last name Hashim, first name Khan, and balance is 12345.90. Update account number 99. It is Hashim Khan 12345.90. Let's draw 23,000 rupees, and let's hope it's assumed. Now let us delete an account. 4, account to be deleted. Let's delete account number 99. Account should be deleted. 2, update account number 99. This means account is not there. Okay, enter your choice. Let's say 2, account number 99 has no information. Okay, so what we have done here, 5 to end program. So 5 to end program. So we have seen that in this random access file we can read randomly, we can update it, we can add new data, we can delete data, and that is only possible because the file is over random access file. So we have created a random access file, and we have carried out different operations on the random access file. This was the part of the demonstration that I wanted to do it in the previous demo, but since I could not do it, so I squeezed some time in this lecture and given you some hands-on demonstration as well. So students, maybe just one more lecture is there. I'll give you some the next topic, and like to see what is the next topic there. Maybe an introduction to something else that we'll see in the next lecture. Till then, Khuda Hafiz, Allah Nigehban.